Alright guys, this is Unit 14, the very last unit of the year. We're going to start by doing Day 1, which is all about what types of studies we do in statistics, what a population versus a sample is, and different types of sampling we can employ in a study. So suppose you want to find out what percent of young drivers in the United States text while driving. Right there, by me posing a question, I have started the statistical process. In order to answer the question, I have to follow the following 3 steps. I need to collect the data in an unbiased manner, organize and analyze it, and then arrive at a conclusion in the context of the original question. This procedure may even sound familiar to you from your science classes when you employ experiments. Statistical studies allow us to generalize characteristics about a population or about any cause and effect. And in statistics, we can't really be 100% certain about our conclusions, but if we've done everything properly, we can be highly confident in them. So our studies fall into 2 broad categories, one being observational studies, and the other being experiments, which you're probably familiar with from science class. Let's start with observational studies. These are studies designed to observe or measure subjects as they are without manipulation or intervention by the researcher. So you're simply watching a sample from a population, studying them, measuring something about them, but you're not actually doing anything to them that would influence any response. And the goal of an observational study is used to describe some group or situation, compare groups, or examine relationships between variables. In an experiment, you are deliberately imposing a treatment on an individual to measure their response. Okay, so observational study is you do nothing to them. Experiment is you do something to them. Now, in an experiment, you have to have a comparison of at least 2 groups. Okay, as you guys are probably familiar with from science, there's always a control group. So that's something that receives no treatment at all. It's kind of like your baseline. Our treatment group is the group that actually receives the treatment, and they can be aware that they're receiving the treatment or not. A way that we could make them not be aware that they're receiving the treatment is giving them something called a placebo, which can be like a sugar pill. They think they're receiving the treatment, but really it's not. It's just sugar. Now, what's important to note here is the only way you can ever conclude cause and effect is by conducting an experiment. You cannot conclude cause and effect from an observational study. You could only conclude some sort of correlation. A proper experiment randomly assigns its subjects to 2 or more separate groups and compares the effects of a treatment or explanatory variable on some outcome, which is the response variable. So you're measuring a response from a treatment that you've imposed. Now, it is important to note that experiments need to be ethical. You don't want to kill people off just to conclude cause and effect, so you can't just do any old experiment you want to do. It's got to be approved. Now, the purpose of an experiment is to determine whether the treatment causes a change in the response. There is one other type of study that we do, and it's called a survey, which I'm sure you guys have done a survey at some point in your life. It's technically neither an observational study nor an experiment, but it's a specific type of study that gathers data by asking people questions and getting their responses. So ask and answer. So a question from above. We're going back to that first question. Suppose we want to find out what percent of young drivers in the United States text while drive. To answer this question, we'll survey 16 to 20-year-olds who live in the United States and drive. Why can't we ask all 16 to 20-year-olds? Well, do you think it would be practical to go and ask every single 16 to 20-year-old in the entire United States? No, that would take forever. So that wouldn't be very time effective, and it would also be very costly to do that. So I'm going to write down it's not practical or cost or time effective to ask all of them. Okay, and that leads us into the next page. We talk about population versus sample. Okay, a population is the entire group of individuals that we want information about. So in the question about the texting and driving, that would be all the 16 to 20-year-old drivers in the United States. Now, it's impossible, or I shouldn't say impossible, it's not very practical or time or cost effective to ask every single one of them, but I can ask a sample of them. So a sample is a subset of individuals from the population for which we actually collect the data. So picture this representation of every 16 to 20-year-old in the United States. I randomly select a few of them, take them out, and that's my study. Those are the ones I get the answers about. So whatever answers I get from the sample, I can then infer that it's likely the same then for the population. Okay? Now, I've been saying this word random. Okay? It is important that you get a random sample when you do these studies. So starting with just over here on the left, using a random sample used in observational studies. True randomness can be obtained only when we employ tools like random number tables, random number generators, or the flip of a fair coin. Okay, and we'll actually practice this tomorrow in class. This is a portion of what a random number table is. So I'll talk about the random number table for a quick second. How this works is if I assigned each of you in the class a number, so each of you would have a 2-digit number, and as I go through on the random digit table, and I mark off every 2 digits, if your digit of, we'll say 4, say you were number 4 in the class came up, that means, hey, congratulations, you're in my random sample. 19, great, you're in my random sample. Okay, nobody has an 86, so I'd skip that. Nobody has a 54, nobody has a 60, but I bet someone in the class would be a 5, given I gave each of you a random number starting from 1. Okay, so those lucky people that would come up in the random digit string would then be in my sample. Okay, but we'll actually practice that tomorrow. So why is it necessary for randomness? Well, we want our sample to represent the population and avoid any sort of bias or non-representation. So let's say we want to study all U.S. females. We would have to make sure we don't have any males, children, or Canadians in our sample because that wouldn't be representative of U.S. females. Secondly, if you decide then to say, well, I'll just use the NCAA women's basketball team as my sample, those members are very athletic and have a high level of fitness in comparison to all U.S. females. So any conclusions you would draw from that NCAA basketball team would likely not apply to a 70-year-old female retiree. So that's why it's important that you have to kind of get a little bit of everybody in your sample. And in order to do that, we use random sampling. Random assignment, similar, and it's something that we use in experiments. Suppose we have 100 volunteers that are used to test out 2 new drug formulas, A and B. The goal of the drug is to increase levels of good cholesterol. The 100 volunteers or subjects are divided randomly into 2 groups of size 50. Okay, and random assignment in this case could even be the flip of a coin. Let's say I come to you, I flip the coin, you get heads. Heads means you go into group A. If you get tails, you go into group B, and so forth. So it's truly random. The queen is deciding what group you go into. Now this is necessary because what will happen if we put the 50 healthiest subjects all into drug A group? It'll appear that drug A increases HDL much better than drug B, regardless of the drug's actual effects, because you've already put the healthiest people here. So it's going to seem like the drug is doing it when really you just already have the healthiest people in one group. So random assignment ensures that you kind of get the healthiest group, or healthiest people in each of the groups. So you get like a sprinkling of everybody in each of your 2 groups. Okay, so random sampling is getting a random sample from a population. Random assignment is when you already have your random sample, and then you're dividing it further into 2 groups for comparison. Okay, so I've been talking a lot. We're going to look at a couple examples. First thing we're going to do here is figure out what the population and sample is. So each week, a Gallup poll questions a sample of 1,500 adult U.S. residents to determine the national opinion on a wide variety of issues. The sample in this group, it even says, is right here, sample of 1,500 adult U.S. residents. But you have to realize that 1,500 adult U.S. residents is coming from the whole population of adult U.S. residents. Okay? So our population is all adult U.S. residents And the sample that we took was the 1,500 adult U.S. residents. Okay, so that 1,500 I'm using to get information about the whole population. Williamsville East High School Student Council wants feedback on the homecoming activities conducted to make any necessary changes for next year. They decide to survey, They decide to survey 100 students in the school. So the population that Student Council is trying to get information about is all students at Williamsville East. Okay, they want information for everybody. They didn't ask everybody, though. They asked 100 students in the school. So our sample is the 100 students. Okay. So we're going to read through Study A and Study B, and we're going to determine which is the observational study and which is the experiment and how we know. Okay, so Study A. A new dog food specifically designed for older dogs has been developed. A veterinarian wants to test the new food against the dog food currently on the market to see if it improves dogs' health. 30 older dogs were randomly assigned to either the new food group or the current food group. After they were fed either the new or current food for 6 months, their improvement in health was rated. Okay, just based on me reading this, I can tell that that's the experiment, because I'm randomly assigning the dogs into 2 groups for comparison. I'm measuring the treatment, which is the new dog food, and the response is the improvement in health. Okay, so I'm actually going to take a second and fill that in down here. So I'm going to say Study A is the experiment. Okay, and that's because dogs were randomly assigned to 2 groups for comparison. And a treatment was imposed. That was the dog food. Okay, so Study B is likely going to be the observational study, but let's see why. Okay, the administration at a large high school wanted to determine if there was a difference in the mean number of text messages sent by 9th grade students and 11th grade students during the day. Each person in a random sample of 30 9th grade students was asked how many text messages he or she sent per day. Each person in another random sample of 30 11th grade students was asked how many text messages they sent in a day. The difference in the mean number of texts per day was calculated. Now, while there were 2 groups that were created here for comparison, they were 2 randomly selected groups and nothing was done to them. Okay, you weren't imposing any sort of treatment on them that would cause them to send more or less text messages. You were simply just measuring how many texts each group sent. So that's why this is an observational study. Students were only observed or surveyed, and their treatment, and no treatment was imposed. Okay. For B, we're going to identify the population of interest in the observational study. So that was Study B. Population of interest was our 9th and 11th graders at a large high school. Okay? In the experiment, what was the explanatory variable? Explanatory is just another way of saying treatment. The treatment we were imposing was a new type of dog food, right? So our treatment is the type of dog food. So that was our new dog food versus the current. What were we measuring? So what was the response? We were measuring their health level. So we imposed a treatment, we measured a response. How many treatment groups were in there? We had 2. One was our control, which was our current. So our current dog food. And that was for 6 months. And the other one was our new dog food. Okay, and each of those were for 2 months. Or, excuse me, 6 months. Alright, so we're going to do the same thing. Read through the studies, decide whether they are experimental or observational or a survey. If it's an observational study, we're going to identify the population. If it's an experiment, we'll identify the treatment and response variables. A study investigated whether boys are quicker at learning video games than girls. 20 randomly selected boys and 20 randomly selected girls played video games that they had never played before. The time it took them to reach a certain level of expertise was recorded. Is this an experiment, an observational study, or a survey? I could eliminate survey because I wasn't asking them any questions and recording their responses. So it comes down to, when I randomly selected my groups, did I impose any sort of treatment on them that would cause them to respond a certain way? And the answer is no, I didn't do anything to them. I simply gave them a game, asked them to play, and I measured then or observed what their response was, I measured how long it took them then to reach a certain level of expertise. Okay, so this is an observational study. Okay, so again, the reason is there was no intervention done by the researcher. Subjects were studied as is. So while I am comparing boys versus girls, I wasn't doing anything to them to influence their responses. Since this is an observational study, I have to ask what the population is. Population is all boys and girls, because we're investigating boys and girls. While it didn't ask for it, my sample would be the 20 randomly selected boys and 20 randomly selected girls. As your statistics project, you collect data by posing 5 questions on a poster board around your classroom and recording how your classmates respond to them. You're asking questions and getting student responses, so this is a survey. You're asking questions and you're recording answers. A professional sports team traded its best player. The local television station wanted to find out what the fans thought of the trade. At the beginning of the evening news program, they asked viewers to call one number they favored about the trade and a different number if they were opposed to it. So they called one number if they were in favor, called a different number if they were opposed. At the end of the news program, they announced that 53.7% of callers favored the trade. Okay, so this one's a little tricky. This one's actually a survey because you're asking a question, are you in favor, are you not? And people are volunteering their answers. So you're still asking questions, recording answers, so same idea there. But I do want to point out that you didn't randomly select who was responding to this. In fact, the responders were just volunteers. So this isn't the best way of getting answers, but this is what you'll oftentimes hear on, say, radio stations. It's really only those people that truly feel passionate about this kind of thing that call in. Okay, so responses. were not randomly selected. Listeners volunteered responses. Okay. The local Department of Transportation is responsible for maintaining lane and edge lines on its paved roads. There are 2 new paint products on the market. 20 comparable stretches of road are identified. Paint A is randomly assigned to 10 stretches of road, and paint B to the other 10. The department finds that paint B lasts longer. The key here is that they're saying that they have stretches of road, 20, and 10 of them are getting randomly assigned a certain paint. That random assignment is telling me this is an experiment. Okay, paint type was randomly assigned. Randomly assigned stretches of road. So again, I'll kind of off to the side here, you have your 20 road stretches. It could be something as simple as heads. This road will go over to get paint type A. Tails, this road will get paint type B. And that's how you would randomly assign the stretches to the certain type of paint. So there's no bias in which one you put into which group. Okay. The treatment in this experiment is what we're doing to the roads. So the treatment is the paint type. So that's A versus B. The response variable is what we're measuring. We were measuring how long the paint lasted. So we'll say durability of paint. Okay, so hopefully this is making sense in how I'm digesting these studies and putting them into certain categories. Let's skip ahead to number 4. For the following is the state conclusion reasonable? Why or why not? A study found a positive relationship between the happiness of elderly people and the number of pets they have. Therefore, having more pets causes elderly people to be happier. So basically what this is asking is it okay for me to conclude cause and effect here? Okay, elderly people were happier when they had pets, so therefore pets must cause elderly people to be happier. I technically can't say cause and effect here because there's nothing to claim that there was an experiment being done. So that goes back to one of the first things I said about experiments. Experiments allow us to conclude cause and effect. This seems to be I just am observing elderly people being happier with the pets that they have. So therefore, I can't say that there's a cause and effect happening here. So there was nothing to indicate an experiment was conducted. So we can't conclude cause and effect. Okay. A researcher wanted to find out whether higher levels of a certain drug given to experimental rats would decrease the time it took for them to complete a given maze to find food. Why would the researcher have to carry out an experiment rather than an observational study? Well, he's looking to show whether a certain drug decreases the time it took them to complete a maze. So he's looking to show that a drug causes the rat to find the food faster. Describe an experiment that the researcher might carry out based on 30 comparable rats and 3 dosage levels. So we have our 30 rats, and we want to divvy them up into 3 about equally sized groups, so we'll say 10, 10, and 10. And those 10 rats would also be divided up by how many milligrams of the drug they're getting. So 0 milligrams, that would be my control group. 1 milligram would be a treatment group, and 2 milligrams would be another treatment group. Okay, and I'm going to compare those. In order to split those rats up, I'd have to use random assignment. So it could be something as flipping a coin. 2 heads gets you in the first group, 2 tails gets you in the second group, and a head and a tail gets you into the third group. Or we can employ something like each rat is assigned a random digit, and then we use the random digit table to decide who goes where. The whole idea of random digits tables we'll actually get into tomorrow by breaking up groups into, or breaking up students into groups for a field trip for Darien Lake. And no, you're not going to Darien Lake. Kind of sounded like we were going to, but in theory, how could we break up kids to go on a field trip to Darien Lake? Okay, so sorry I couldn't be there in class, but hopefully this lesson makes sense. Complete the homework for tonight, and we can talk more about it tomorrow.
Hey Harley, come here. He always likes to run away with the treats.